Thank you for attending our session today, The Evolution of Machine Learning on Hybrid Cloud. Hi, I'm Michelle Wallig, and today I'll be joined by Jarapat Hito, who will also have some demos for us shortly. So our agenda today is really to cover a few things. The machine learning in Azure SQL hybrid cloud has several value propositions, which we will cover. Then we'll look at the architecture in the hybrid cloud and the different opportunities there. Finally, we will show you some demos, share a little bit about the roadmap, and do a 15-minute Q&A. On this slide, just some contact and background information for Jarapat and I. First on our agenda is the value propositions for machine learning in the Azure SQL hybrid cloud. We're going to talk a little bit about why machine learning in hybrid cloud. So in 2017, we shared the basic premise of an intelligence database pattern. This is when you push intelligence to where your data lives. When you do this with an industrial strength database engine like SQL Server, you can get throughput, parallelism, security, reliability, compliance certifications, and manageability all in one. It's a big win for developers. You don't have to build separate servers for the database and the data science activities. Furthermore, just like data in databases can be shared across multiple applications, you can now share the predictive models. Models and intelligence become yet another type of data managed by the DBMS. In summary, you can bring intelligence to where your data lives on the most trusted and performant platform with any language, any platform, anywhere. As a data scientist working from my Python IDE, I can execute Python code that runs in SQL Server on the data in SQL Server, and I get the best results back in my IDE. I can leverage any open source Python package for machine learning. As an application developer, I can call T-SQL stored procedures to trigger execution of Python code and get the results, scores, predictions, plots back in my application. So some of the advantages include eliminating data movement. You are doing your models in the same server as where your data resides. Therefore, in that database server, you leverage the security that comes inherent in that server, as well as you can push, therefore, your machine learning compute to the database. In newer, more current applications, you can also isolate your ontologies from the transactional database. That means you don't have to necessarily bring over the PII data that's inherent in your transactional database in order to build models and train models and score models in your database. You can use the ontology that would have the data that you would need to build your patterns without the PII. It's also easier to operationalize your scripts and models and put them in production in your applications by calling familiar T-SQL stored procedures that have the ability to embed your machine learning scripts, as well as use the model management already available in SQL Server. In addition, when you're in a hybrid cloud, you can use the native scoring capabilities or more recently convert to an Onyx model. I'm going to go over an Onyx model in the next slide. All of this leads to enterprise-grade performance and security. So you can currently in SQL Server, obviously multi-thread and do your parallel processing to get through your data in a much more efficient and performant way while scaling your R and Python analytics. You can leverage the hybrid cloud Azure and SQL security, compliance, resource governance, query performance, and always-on secondaries capabilities. And as you have in your enterprise databases across different types, you can also create knowledge graphs that would leverage data from wherever it resides. I'm going to also describe a little bit more about how machine learning is available in a platform as a service called Azure SQL Managed Instance, Synapse, and Edge. So again, you can leverage different language integrations that we've created recently. You can have extensibility framework using Java, R, and Python. And more recently, about a month ago, we also open sourced R and Python custom runtime, so you could bring different versions of the languages that you need to in your model building. Microsoft has partnered with AWS and Facebook, SAS, and others to support ONNX, or Open Neural Network Exchange. ONNX is an open format that supports the storing and porting of predictive models across libraries and languages. Most deep learning libraries support it, according to Katie Nuggets. Later on, Jarapat will demonstrate a logistic regression model conversion to ONNX and the goals shown here. Inference or model scoring is the phase where the deployed model is used for prediction, most commonly on production data. In this next section, we will talk about the different machine learning architectures available in different hybrid cloud opportunities. Imagine how you can use the models you developed on-premise and move them to the hybrid cloud. For example, as a scenario, you can secure the data on-premise and move your ontology to the cloud without the PII to score using the scale and efficiency of the cloud infrastructure. Microsoft Azure Hybrid Cloud is comprised of platforms ranging from SQL Server to big data clusters on-premise to Azure SQL Managed Instance and Azure Synapse Analytics in the cloud. Starting with SQL Server 2019, SQL Server Big Data Clusters allows you to deploy scalable clusters of SQL Server, Spark, and HDFS containers running on Kubernetes. These components are running side by side to enable you to read, write, and process big data from Transact SQL or Spark, allowing you to easily combine and analyze your high-value relational data with high-volume big data. You can use SQL Server Big Data Clusters to deploy scalable clusters of SQL Server, Spark, and HDFS containers running on Kubernetes, read, write, and process big data from Transact SQL or Spark, easily combine and analyze high-value relational data with high-volume big data, query external data sources, store big data in HDFS managed by SQL Server, query data from multiple external data sources through the cluster, use the data for AI, machine learning, and other analysis tasks. Also, deploying and running applications are available in big data clusters, while virtualizing data with Polybase, query data from external SQL Server, Oracle, Teradata, MongoDB, and ODBC data sources and external tables. It will provide high availability for SQL Server master instance and all databases by using the always-on availability group technology. In the cloud, we have Azure SQL Managed Instance, which is designed for customers looking to migrate a large number of apps from an on-premise or IaaS, self-built, or ISV-provided environment to a fully managed PaaS cloud environment, with as low a migration effort as possible. Using the fully automated Azure Data Migration Services, customers can lift and shift their existing SQL Server instance to managed instance, which offers compatibility with SQL Server and complete isolation customer instances with native VNet support. With software assurance, you can exchange your existing licenses for discounted rates on SQL Managed Instance using the Azure Hybrid benefit for SQL Server. SQL Managed Instance is the best migration destination in the cloud for SQL Server instances that require high security and rich programmability services. Azure Synapse Analytics is a service that brings together enterprise data warehousing and big data analytics. It gives you the freedom to query data on your terms using either serverless, on-demand, or provisioned resources at scale. Azure Synapse brings these two worlds together with a unified experience to ingest, prepare, manage, and serve data for immediate BI and machine learning needs. Azure Synapse has 4 components. Azure Synapse Complete T-SQL-based analytics, which is now generally available. Spark, with deeply integrated Apache Spark in preview. Synapse Pipeline, which is hybrid data integration, also in preview. And finally, Studio, a unified user experience currently in preview as well. In a cloud data solution, data is ingested into big data stores from a variety of sources. Once in a big data store, Hadoop, Spark, and machine learning algorithms prepare and train the data. When the data is ready for complete analysis, Synapse SQL Pool uses Polybase to query the big data stores. Polybase uses standard T-SQL queries to bring the data into Synapse SQL Pool tables. Synapse SQL Pool stores data in relational tables with columnar storage. This format significantly reduces the data storage costs and improves query performance. Once data is stored, you can run analytics at massive scale. Compared to traditional database systems, analysis queries finish in seconds instead of minutes or hours instead of days. The analysis results can go to worldwide reporting databases or applications. Business analysts can then gain insights to make well-informed decisions. Later on, Jarapat has 2 demos, one using the Azure Data Studio in a managed instance environment, and 2, she will show you how to do a machine learning model in Synapse. Next, I just want to spend a few minutes talking about in-database machine learning. So you can basically start developing and experimenting in your favorite data science tool, whether it's R or Python. And it's easier to debug and experiment this way until you're happy with the model. Once you're ready to deploy, you can train the model in the database by moving your R or Python code into SQL Server inside a special stored procedure called stored procedure execute external script. Once the model is generated, you save the model to a database table, and now you can use that model to predict an outcome. In this next session, Jarapat will share with you 3 different demos. The first demo we have for you today is really to show a pattern of hybrid cloud machine learning that will help democratize machine learning across different roles. So for DBAs and data engineers, it's really about the ingestion and management of the data structures that will be used by the data scientists and analysts in creating their models, training, scoring, developing, and building their models. The data developers will then be able to put those models into applications. So we have the Azure Data Studio demo to show you what that would look like for all these roles.
In this demo, I will be showing you how to use machine learning extension in Azure Data Studio to manage packages in R or Python and manage models in Azure SQL Managed Instance and Azure SQL Edge. I have installed machine learning extension in my Azure Data Studio. I am connecting to my Azure SQL Managed Instance. I'm going to go ahead, right-click and select Manage. This will open up a new window. From here, I can select Machine Learning to open up Machine Learning extension view. I can select Manage Packages in Database. This will open up a new pane that will list all the packages that I have installed on my instance. This will list the Python packages that I have in my instance. I can select Add New to search for Python packages to install or update existing packages. The extension will list all the version that is available for that package. I'm gonna go ahead and close this because I'm not gonna install or update existing packages. Next, I'm gonna show you how to manage model in my SQL instance. I'm gonna select Import or View Model. I will have to pick a database and a table that contains my model. In this case, it's already pre-selected for me. I only have one model in that models table. I will import a model from my local machine to my Azure SQL Managed instance. I'm gonna go ahead and select Import Models. From here, there are two options, either file upload or import a model from Azure Machine Learning. Since I have my model on my local machine, I'm gonna select file upload. I will be selecting the model files. I can enter the name and the description of the model. Then I can select which database and which table this model will be uploaded to. In this case, I have models table pre-created already, so I will be using that. If I do not have the table, I can choose to create a new table and the extension will create a table for me. I'm gonna go ahead and click Deploy, which will upload the model from my local machine into my Azure SQL Managed instance. And you can see that the new model is uploaded into a models table. I'm gonna go ahead and close this. We can also confirm that the model is uploaded by selecting from models table. You can see that our new model is already uploaded into the models table. Next, we will be using this model to do a prediction on the data that I have in my database. I'm gonna switch back to, again, machine learning extension, click Make Prediction. This will open up a new window that asks me, where is my model? Since I'm already imported my model into the database, I'm gonna select the first option. It will then ask me which database and which table I store my model. And I will be selecting the second model, which is the one that I just uploaded. From here, we have to select the data source that we will use for a prediction. For this scenario, I have a data of New York City taxi trips that will contains whether the user will decide to tip or not. So we will use the model to predict for this particular trip whether the customer will decide to tip the taxi or not. As you can see, the extension is already pre-populated the column from the table with the column that requires for the model. It is also detecting the output from the model. Once I click Predict, the extension will generate a SQL script that I can use to do a prediction. I am going to modify some script because I would like the script to make a prediction for all my data. And I know that my last column is a worker 30, so I will be modifying that as well. And I'm going to remove the output probability because I do not need that. Now my script is looking good. I'm just going to go ahead and run the script. You can see that the output, the first couple columns come from my data source, which is NYC taxi tips table. The last column is the prediction from my model. The model is selected from our models table. We get an input from our data table, and we run a predict on that information. To conclude, I have shown you in this demo that we can use machine learning extension in Azure Data Studio to manage R or Python packages and to manage model in Azure SQL Managed Instance and Azure SQL Edge. Thank you.
In this next demo, the next pattern of the hybrid cloud machine learning is to build a model on managed instance. This diagram shows where managed instance fits within the platform as a service set of tools and environments. Enjoy the demo.
Hello everyone. In this demo, I am going to show you how to run a Python machine learning script on Azure SQL Managed Instance. Currently, I am connecting to Azure SQL Managed Instance, which I have created. In this demo, we will train a model to classify 3 different species of iris flower. I already have a data in a table called iris data. Let's have a look at the data. This is a small data set of only 150 rows, which is fine for the purpose of this demo. I will be using a store procedure which will execute a Python script. In the Python script, I am training a machine learning model using logistic regression method. After that, I will convert a model into an ONNX format. The ONNX model is an output of this store procedure. I will be using the data from my iris data table to train my model. I will go ahead and create this store procedure. Then I will run the store procedure to create and insert a model into a model table. Currently, we do not have anything in the model table. I will go ahead and run this. Then take a look at the model table again. We can see that now we have a model in the model table. Typically, we would want to split the training and testing dataset. However, for this demo, I am using the same dataset for training the model and doing a prediction. This query will return the output of the prediction in an output label column. It will also return the input data we use for prediction as well. First column is the output of the prediction. As you can see, there are some incorrect predictions, which means we should be able to improve our model. But this is out of the scope for this demo. To conclude, in this demo, I have shown that we can build a machine learning model and run a prediction using a model on Azure SQL Managed Instance using in-database machine learning services feature. Thank you.
Azure Synapse Analytics is key to helping manage large relational data warehouse repositories. The next demo will show how scoring is done in Synapse.
Today I will be showing how to do a prediction in Azure Synapse Analytics using a machine learning model created by Azure Machine Learning. Currently, I am using Azure Synapse Studios to explore data in Synapse Analytics. What I have here is an Azure Synapse Analytics workspace with SQL pools. I also created a linked service to Azure Machine Learning. Here, I already trained a model in Azure Machine Learning. We will be using machine learning model to predict if the customer will tip in a taxi ride. The input dataset is stored in NYC taxi tip table, which is this table. I'm going to run this to show you the data. The dataset contains the information for each taxi tip in New York City. From the table, I can select an action, machine learning, enrich with existing model. This will load the model from my Azure Machine Learning workspace. I'll be using NYC Taxi Tip Predict, the second one. Click Continue. The wizard will auto-populate the model input and read the column from the table and map that column with the model input. I'll be selecting all of this column. The wizard also doing the same thing for the output. Then we will have to name the store procedure. This store procedure will be the one we use to do a prediction or scoring. Then the model will be uploaded from Azure Machine Learning to Azure Synapse Analytics. So we will have to select a table to store the model. I already have a table called models that pre-created, and the model will be uploaded here. I will not be doing a deploy and open the script because I already deployed the model and we have a script generated. This is the script generated from the wizard. It will be selecting the model from models table with an ID NYC taxi tips. Once the store procedure is created, I can execute this store procedure, which will do the scoring by reading the data from NYC taxi tips. As you can see, the first column is the output of the prediction. The rest of the columns are the input data from the NYC taxi tips table. For more complex predict scenario, we can also combine predict query with aggregation or do a nested query. In this example, we are using a different model to predict the cost of a taxi trip around New York City. We will find the average fare amount for the number of passengers and then rank them. As you can see, the inner query is using a predict from a model that we already trained. And then we will find the average. Total amount is the output from the predict statement. And we can do a run over the output. We can also create a view on top of the predict query. The view can then be used later on with BI dashboard or some other analytics dashboard that built on top of the query.
In the next section, I'm excited to share with you some of the roadmap items we have coming up. We have 4 roadmap items I'm really excited to share with you. The first one is a preview that we've been doing since June, and it's the machine learning on Azure SQL Managed Instance, which we demoed to you earlier using Azure Data Studio as a user experience. That is targeted to GA in a couple of months. We've been working with about a couple dozen customers to help them with moving their machine learning environments and models to a managed instance so that they can see the performance and the ease of deployment, lift and shift into the managed instance, as well as all the capabilities that come inherently in a PaaS environment. The second release we'll be building some machine learning services within the Azure Arc enabled data services that have just been released during the early fall and was announced at Ignite. The third release involves big data clusters, where we will bring, again, the machine learning services to that environment and provide containerized capabilities within the Kubernetes using machine learning services. And finally, there will be a GA by the end of the year for machine learning on Synapse. To recap, 3 takeaways regarding the Azure hybrid cloud. We can move what you already have and move it to the hybrid cloud through some of the capabilities I shared with you today. Recently, we also had made available custom runtimes for R and Python, as well as you can use extensions for Java, R, and Python. And the third takeaway is the continued expansion in 2021 into the Azure Arc environment, as well as big data clusters. In the slide deck, I've also compiled additional resources for all the topics that we covered today. And thanks for attending our session today. Jarapat and I are here for 15 minutes to answer any questions you may have.